You type youtube.com and hit enter. About 300 milliseconds later, the page is on your screen. In that blink, your laptop talked to 4 different machines and fired off dozens of requests. Here's the entire journey. First, your browser tears that URL apart. HTTPS means use encryption. YouTube.com names the server. Anything after the slash is the exact page you want. But here's the catch. YouTube.com means nothing to the network. The internet routes traffic to IP addresses, numbers like 142.250, 190.78, not names. So before your browser can send a single byte, it needs to turn that name into a number. That translation is DNS. Your machine checks 4 caches in order: browser, operating system, router, then your internet provider's resolver. And the first hit wins. Miss them all, and the resolver walks the global hierarchy until someone answers. We trace that full journey in our DNS video. Card above if you want the deep dive. Either way, an IP comes back in milliseconds. If you enjoy seeing what the internet hides under the hood, subscribe. More of this is coming. Now, time to knock on that server's door. Your browser opens a TCP connection to that IP on port 443. Think of ports as numbered doors on the server, and 443 is the one for encrypted web traffic. The setup works like a phone call. Your laptop says sign, "Can we talk?" The server replies, "Synac, yes. Can you hear me?" Your laptop confirms, ACK. 3 messages, 1 round trip, and both sides now number every packet so nothing gets lost or arrives out of order. The line is open, but it isn't private. Anyone sitting between you and the server can still read everything. So both sides run the TLS handshake. The server shows a certificate proving it really is youtube.com. Then both sides agree on an encryption key no eavesdropper can compute. That's the padlock in your address bar. And there's a whole video on this channel unpacking exactly how that magic works. From here, everything on the wire is scrambled. Time to ask for the page. Your browser sends an HTTP request, GET, the path you asked for, and headers, browser type, language, cookies, and it doesn't send just one. Over HTTP2, dozens of requests share this single connection simultaneously. No waiting in line, responses interleave on one wire. The server answers each with a status code. 200 means OK. Headers, and the data itself, streaming back in chunks of a few kilobytes. But which server actually answered? Probably not the one you think. YouTube doesn't serve you from one data center in California. It runs a CDN, content delivery network, thousands of edge servers parked in cities worldwide, each holding copies of popular files. Your request lands on one a few miles away. That matters because light is slow. A round trip across the planet costs 200 milliseconds. Across town, 5. Multiply by dozens of requests, and the edge server is the difference between instant and sluggish. The HTML arrives. Now the real work starts. Your browser reads the HTML top to bottom and builds a tree from it. The DOM. Every tag becomes a node. Style sheets get passed into their own tree of rules, the CSOM. And buried in that HTML, more URLs, style sheets, scripts, fonts, images, each firing another request as it's discovered. One type is special, JavaScript. Hit a script tag and parsing stops dead until it downloads and runs, because scripts can rewrite the page mid-build. That pause is why heavy scripts make fast networks feel slow. With DOM and CSOM merged, the browser runs layout, computing the exact position and size of every element, then paint, filling them with actual pixels, then compositing the layers together on your screen. A typical page fires 70 or more requests to get here. Guess how many this page made? Drop your number in the comments, then press F12 and check the network tab. From enter key to finished page, usually under a second. Name to number, handshake, encrypt, request, render. 5 steps, hundreds of times a day, all in a blink. Subscribe for more looks under the internet's hood.